Okay. Yeah. So let me share my screen. I hope my screen is visible to all.
Not at yeah, now it is.
Okay. So yesterday we saw we were seeing what is the difference between on-premise, cloud, and very in a very basic, simple way we were trying to understand, right? So we will continue from there. We will continue on our topics like what is cloud, and then we will slowly move on to the CDN and all those. So let me. Okay. Why is- Okay, so let me draw the diagram again, which we drew yesterday very quickly. My voice is audible to all, right? I think some network jitteriness is there today.
No, voice is good, sir.
Yeah, okay. Just let me check if any. So I heard Tirupati is in Vishakhapatnam now. Is it Tirupati? Vizag.
Yes, sir. When you're coming, just
Okay.
visit to me.
Sure, sure. Yes, yes. Want to visit. Heard a lot about Vishakhapatnam.
Then
Maybe when I
visit.
plan my Andaman trip, no, that time I will come there.
Surely. Come, sir.
Yeah. I heard through Vishakhapatnam we have some travel, right, to Andaman.
Yeah. My life is entire gone, sir. I went to almost in Maharashtra almost in more than 15 years.
Oh, okay.
After
That's
long
good
back,
only,
I
no?
came to, so my son and daughter was already completed in 10th standard in Pune. So that's the reason we shifted to here.
Oh, okay, okay.
They all joined, both are joined in plus 11th standard and 12th standard. That's the reason.
That got it,
Anyway,
got
we
it.
are
Yeah.
working. Anyway, we are working for home side from long back, almost more than 4 to 5 years.
Hmm.
I'm working from home, so
Okay.
that's the reason. Yeah.
So lucky. I don't think all are now
Nowadays, very
working from
difficult.
home.
Yeah, yeah.
Yeah, yeah.
Nowadays, very for me, my company people they never asking to office.
Okay. Hmm. That's good.
Yeah, that is client. Client is never asking. That is HSBC.
Oh, okay. Nice.
Yeah,
Oh, HSBC is allowing you to
yeah,
work
yeah.
from home. Ah,
Exactly,
that's good. Though they are into financial services, they're okay.
exactly. So even
Okay.
Mastercard
Nice.
also they're allowed last year. Yeah,
Nice. Yeah, we have a mandate of 3 days a week.
exactly.
Yeah,
Nowadays everything. That is the reason I'm not looking to other thing. Why? Because if you try again, so definitely they will ask you at least weekly one time you come back.
correct. Yes. Okay, so this is a high level architecture we saw, right? And these were the components that we were slowly discussing. Now, see, when we speak about on premise or cloud, right? The machines that are there on the cloud will host our application. Now, whatever you are seeing in this, right? The load balancer, middleware, web server, app server, DB server, all these things are various softwares. Is that part clear to all? So, for example, if I say web server, I can call out Apache Tomcat. Apache Tomcat is a web server. So, like we install Google Chrome, like that, we have to install that application, that Apache Tomcat, which will act like a server. So, I put my code in that Apache Tomcat. For example, let's say I have, I think, Tomcat. Let me show you very quickly how it happens. Um, Yeah. So see, this is Apache Tomcat server files. Okay. Now in that web apps, see you can see all the different web apps. So for example, Jenkins is here. So all the Jenkins files are here. Now, due to this only that Jenkins runs like you are able to access it through the network and all. No. So for example, this is a JPEG store application. These are the files of that. For example, this is the index file of that. So this is HTML. So if you just open it, this is my code, right? Not my code, I'm saying the application code. If you see, it is written in HTML. So now these are the files of my application. Let's say I've written the HTML code and this is the files of that. Okay. Now this I have put it inside my Tomcat application. Okay, now when I run Tomcat, this application also will run, right? That's how. So this web server is Apache Tomcat. So you need a web server to run your application, right? Now, again, this is not that important for you as a QA, but you need to know which web server you are using, whether it's a Tomcat, Nginx, because each web server have a different tuning mechanism. Okay, so especially when you do performance engineering, not testing, that time what you will do, no, you will do a lot of tuning activities, optimization. So, for example, there is basically cache settings and all, okay, in the web server, how you cache, how much time you cache, what type of caching you use, how many connections you need to keep alive, so many settings like that we have inside a web server also. So those things we tweak in performance engineering, not in testing. So for that purpose you need to know more about this web server and all. But in a performance testing perspective, you just need to know, okay, what web server we are using, so that we know the characteristic of it. Okay, and then we will be providing the test results and all, so that way things will go. So, and DB server, so we have various again other softwares like Oracle is there, MySQL is there. All these are softwares you can install and your DB server is on. So basically Oracle will give a, when I say DB server, it's a application that's running in my system, whichever I am converting it to a server, and I will be able to use it continuously. Now, my question to all of you is, what is the difference between server and, let's say, some application that is running on my desktop or machine? So I am running my application in server. I am running my application in, let's say, Windows. What's the difference?
Chrome is your client.
So
Client
basically,
side you are
for serve request, basically any system is server which is serving request made by the clients.
Mhm. So my main question is, why do we need do you think, why do we need a server?
Because there
Like,
can be
for example, in our case, I said server is Apache Tomcat. Okay, let's say. So why do I need Apache Tomcat software to run this Amazon.com?
so basically it is providing environment for the application.
Mm,
Java
pretty
environment,
close.
Java
Pretty
environment,
close.
whatever we can say.
Hmm. Little bit more, little refined answer.
To host the data.
And that is different.
See,
can you
now
come
let's
again the
say,
question, please?
do you, I mean, like, maybe not very exactly that example will match this, but when we enter a airport or something, we have that checking, no? Checking door. We pass that, and then there is one more checker who will check. So, why do we need two people? I mean, like, two things. Maybe the checker can check it, or maybe only the door we can keep it. Why we need both? So same way, right? What this web server will do, no? The server application, it will automatically, first of all, enforce all the network rules. Okay? So if your application doesn't follow your network rules, your application will not run. That is one thing. Automatically, it will enforce all the network rules like the protocol, handling the request, storing and serving the content. All these things, it will follow the proper rules and the proper things. So automatically. Second is, it will handle the request properly. See, now Chrome is running in my system, but can Chrome be run by two users at the same time? No, right? Unless it is not on a server, it's two people at the same time cannot use Chrome, right? When it is on the same system. But in server, even multiple users will use Amazon.com, no, at the same time, sessions. So all these things, session handling the client request, all these things your server will handle. Okay. Next is storing and serving the content. So it will store the website files like you saw, no? For example, this is my website files I showed for this application. This is a website file. If I just click on here, this is my application. If you see, enter the
You're
store.
not
But
able
yeah,
to share your
now,
screen.
oh, is it not being shared?
It is.
It's being shared, no?
Yeah.
Who is not able to see the screen? Okay. Anyways, maybe you can rejoin. I think most
Yeah,
of you are able to see the screen, right?
I'll do it.
Yeah. Thank you. Okay, so what will happen? So the session handling. Second and third, okay, third we were seeing storing and the serving the content, right? It will store and serve the content. Here, don't confuse it with DB, okay? Storing, what it will store and serve? JavaScript files, CSS files, HTML files, PHP files, your code files, not your DB, right? DB is totally different, okay? It's a totally different story. These are files, static files, images, then some videos, all this it will store and serve. Okay. Next is it will process the dynamic content. Now it has to run the PHP and all, no? It has to run HTML, it has to run PHP. So that also it will running the code, that respective code, whether PHP, Node.js, whatever, right? It will help us to run the code and that dynamic content will be served. So there is static content, dynamic content that we will explain, we will see later. Okay. Then security and access control, right? That is very important. So again, security and access control it will take care. And again, scaling is very easy and availability also with the server. Okay, it will handle thousands of requests at once, like based on your settings and your system capability and all. Even load balancing also it will do a little bit, especially when you have a clustering and all. Okay, like when you have multiple websites running in the same system and all, it will do sometimes little bit of load balancing also. And protocol, right? HTTPS, it will properly try to manage those things. So overall, the web server will manage many things for you. That's why we need a web server to run an application. So every application will run on a web server, except for Kubernetes, we have a different concept. Okay, we have containers there. They follow a different concept. But generally, any other application that we see online, they either have LAMP or there is something called a LAMP also. So when we say LAMP, can someone think about what's the full form of this LAMP? When we say LAMP, anyone heard about this terminology before? LAMP server or LAMP server?
No, Vishnu.
Okay. So see, whenever you are running any application, this is the bare fundamental minimum things that you need. Okay. So first letter stands for Linux. So your operating system, the system should have some operating system, no? So it's on Linux. Okay. Then we have one web server, that is Apache. Let's say Apache Tomcat. That's what we saw, a web server. Then M stands for MySQL, which is the DB, and P stands for PHP. So this is called LAMP. So any application running online, bare minimum, it will need these four things: DB to store the data, web server to deliver the content, the operating system in which all these things are running, and the PHP code, basically PHP installed. Again, PHP is also software, okay, which we need to install. Then only PHP code you can do and run. Okay, so this is LAMP. Now, what is LAMP? Obviously, three letters are same, no change. Any guess what the E will be? So what happens? No, there is another web server called Nginx. Anyone heard about it before?
Yes, I did.
Yeah,
Right?
yes.
Now this is little
Nginx.
comedy. Okay, then this is little comedy. Like why it became E? Because people called Nginx like this. Okay, so they took E. Okay, that's why they say LAMP. So either you can have an application on Apache Tomcat or you can have it on Nginx based on some architectural considerations that if you are lightweight and you need a lightweight web server which has to handle high traffic, okay, then Nginx is good. But if you need some not you have to, I mean, like you need complex processing, okay, and all, then Apache people go with. Okay, it also can handle higher traffic. It's not that it cannot handle, but it's little Nginx is little lighter, okay, compared to Apache. But it is Apache is very good at handling HTTP requests. Okay, so that's why it is very common. If you will find almost 70% of the websites running online on LAMP.
LAMP
Okay,
is talking about only web servers or the entire architecture?
see now this thing LAMP I said, it is just all these things are running inside one system, right? One CPU. So when I say entire architecture, this is just the backend I'm talking about.
Okay. No.
Okay, are you getting so see, for example, which the diagram that I drew, what is my LAMP stack? My LAMP is actually this much.
Yeah. Correct. Yeah. Got it.
Okay, yeah,
Clear.
that's all. Hmm? Okay, so okay, now coming to this. So that's the thing about the web server and all. Okay, so web server story is that. Now coming to DB server. So DB server is also like web server only, but especially for DB. So generally the most common DBs that you would have heard is Oracle and MySQL. Okay, they all are they both are relational DBs. We call it. Different types of DBs are there. Time series DB is there. Then time series DBs are mainly for storing time related data, like let's say ECG, or especially our performance testing monitoring. No, all these things are time series. So they store time in, they are better stored in time series DBs. Okay, now we have relational DBs. These are Oracle and MySQL. There are NoSQL DBs. Okay, different types of DBs, but Oracle and MySQL are very common ones. And you, so what is DB server? In this, my Oracle software will run or MySQL software will run, which will provide me a DB also. So maybe I can show you that also quickly. For example, I have MySQL with me. So this is my MySQL workbench, which is a software we use to access the MySQL DB installed in some remote server. Okay. So for example, this is one DB that I have. Okay, I think I have to connect to the VPN. Let me quickly connect to VPN. These are something which is I'm showing it from my personal thing. Okay, so that's why I have to connect to VPN. Just a moment, I'm connecting. Okay, now VPN is connected. Hopefully connection remains alive. Okay, able to see my screen now again?
Yes, Vishnu.
Yeah. So see, now this is my DB, right? For example, this admin admin.pr is my DB. There are various tables, store procedures, functions. Now inside I have tables, okay, queries and all written. Okay, for example, now this is a let's say a motivation table which has rows and columns. So this is how the table looks like in a DB. Okay, it is storing different data, right? Title, description, code, and you have various queries. You know, it is one query that I ran to print out this table. Select star from this DB and this table. That's the meaning of this. Now I can further filter, okay, by putting, let's say, where clause, where let's say mode underscore code. I'm not that good at writing SQL, frankly, but just to show I'm writing, okay. So this equal to, I think we write it. Surely there will be a syntax error. No, okay. Okay, so see, now I have filtered only that row which has mode code BL, right? Initially we had all. So select star is for printing all the things in that table. Now putting a where clause, what I have done is I have filtered it out, right? That's what I have done. Now I'm removing where clause again, I get all the data again. So this is how the DB works. So this is a query that I'm running, right? So whenever, so what happens now? Let me explain that, okay? So let's say I wrote a PHP code, okay, something like PHP and some code I wrote. See, now these things don't need to worry. You will not write it as a performance tester, but you need to understand how these things work, right? Like the fundamental way. So I wrote a PHP code and I wrote some function, get customer details, okay, something like that. And in this, what I'll do now, I just do dollar details is equal to, I will just do SQL and I'll run the, let's say this query, select star and whatever, what is it, from something, okay, from something, okay. Now, when in my code, this function is called, it will run this query in the DB, right? That's how it happens in the code, right? So now my question to all of you is, if in this function, I don't have this line, okay, just I'm doing some print some hello, will it go to DB?
No.
It will not go, right? So that time there is no load on the DB. So as a performance tester, this time there is no load on the DB, right? That is important for us to know. Here there will be load on the DB because we are calling the query, right? So if now the same thing, get customer details. Now when is this activated? Let's say when someone clicks on a button, get customer. Let's say in the front end in my website there is a button. Okay, when they click on this button, this function is called. Now if this button is clicked 100 times, okay, and let's say this query is there in that function, so how many times the query will get executed if someone clicks on this button 100 times?
100
So
times.
each time yes, exactly, right, 100 times the query will get executed. So that's how now each time when the number of queries getting executed increases, where the load will increase on the DB server, because this is where my DB is running, right? My database is running. So there my load will increase, and if the CPU is not able to, the CPU, let's say I have given 4 core, RAM I have given, let's say 16 GB for the DB server. Okay. Now if it is not able to take in this, it will crash. So I will have to give more resource so that it can take more, it can run more queries, or I have to optimize the way a DB is getting called so that it can work inside this CPU limits. Something I have to do with that, right? So that's how things happen. Are you getting, all of you, why I am trying to explain these things? Are you able
Yes.
to correlate?
Yes.
Okay. Yeah. So are you now getting a picture, or let me put this question this way, before and after? Before, when you thought about what's a DB server, and now when you think about a DB server, is there a difference? Are you in a better place to imagine what's a DB server now compared to yesterday?
There is.
Yes, Vishnu.
Okay. Yeah. So that is main thing. Okay. So as a QA, these things will help you to find out or go deeper into some issues and uncover some major issues, right? Now let me show you one more thing. So let's say uh, now due to some reason in my code, okay, this let's say my code is this function, some get, some function is there, let's say, and I have a for loop. I'm not writing everything, okay, just, and I have, let's say, a data. Okay, and I am let's say printing that data. So what basically this for loop is doing is when I click on, let's say, a button get, this function will get triggered, and that will run a for loop, let's say 10 times. Okay, so each time, let's say, I value will change inside my query, let's say select, okay, some $I, okay, some value will change, and it will print that data, okay, 10 times, 10 different types of data. Now I did the testing. So when I did testing, this get button was clicked 1,000 times in, let's say, 100 seconds. So per second, how many times the button is clicked? How many times? 1,000 times in 100 seconds. So in 1 second, how many times?
10.
10 times.
10 times. Okay. So 10 times in 1 second. So basically, let's assume that I ran a test with 10 users. Okay, that's why it is clicking 10 times in a second. Okay, let's assume. So when it ran 1,000 times, now each time this query is running how much? 10 times, because it's in a 10 loop. No, so 1,000 times into 10, which is 10,000 times. So 10,000 times my query has run. Are you getting the point, all of you? Though I have
Yes.
run the button only 1,000 times, my query has run 10,000 times. So the load on the DB server is very high. Though my server, it's easy. It's just 1,000. In the web server, I'm seeing only 1,000. Apache Tomcat is seeing only 1,000 load. But on the DB, the load is, the number of hits are high, right? Due to this loop and all. So now this sort of situation, sometimes what will happen is it will crash my DB server. Okay, because the number of times the query is getting called is huge. Okay, so what we do, we try to optimize it. So what we optimize, we means like if you are in a range of 8 years plus or 7 years plus, you can give this optimization techniques to the developers also. Otherwise, developer will optimize it. You just show that this is a problem. Okay, they will optimize it. But let's say if you're optimizing, what I can say, instead of calling it 10 times, what is the need, I will understand, right? When I'm clicking get, do I really need to print all the 10 always? Or I am printing it because from that I am extracting some one value, and that is the main thing which I need to print. Okay, something like that. So what I can do, if that is the case, instead of running 10 times, I will run a query with a filter which will reduce the load from 10 to 1 just by adding a filter, and that's all. My load will become 1,000 times compared to 10,000 times, and the DB server will work well because I have reduced the load 1/10. Are you getting, all of you, what I am trying to say?
Yes, yes, for sure.
Yes.
Yes, I got
Yeah.
it point.
So this is one way, right? Like I'm just bringing you to a point where you start thinking like a performance expert, right? Like how things should perform well, right? How you can make it less resource intensive, because in this era of resources are very costly, expensive. Okay. Now you would have heard about some AI institutions who are running out of resources. Heard about it?
Yes.
They are not getting enough compute. So that's why you would have seen this Nvidia stocks have shot, right? Nvidia stocks have shot because they are the main providers of GPUs, right? Which is a very driving factor of AI. Like CPU, we have GPU. Okay, so resources are becoming very expensive, and going ahead, it will become more expensive. Okay, so if your application is currently running on 5 CPUs, even by your performance testing, even if your client can reduce this 5 CPU to 3 CPU, it's a big deal for them, because in a year they will save almost, let's say, 40% of their total expense because of your performance testing. So now, to give you a proper idea, let me explain you this. I have worked with a client, like before I was working. So there they were using AWS. Okay, and can you imagine, they are a very big fast food chain. I don't want to call it out. And they are number one in the world. Okay, uh, what do you think? Like, how much would they be paying in a year to AWS for the resources? Any rough number?
10 million
So 10 million is how much? So 10 million is, let's say, 1 crore.
US
You are
dollar.
saying dollar?
Yeah.
Ah, so let's multiply by 85. 85 crore. Okay, what's the next number? 85 crore is one number. Go higher. Can it, anyone with 500 crore number? Again higher. Anyone with 800 crore? Again
One
higher. They are
1,000
paying
crore.
1,250 crores a year.
Oh my god.
Okay, to AWS. Now think, as a performance tester, if you reduce even 1% of this, okay, like 1% utilization, you are able to reduce just 1%. I'm saying, okay, overall. So it comes to almost 12 crore. So
Yeah.
will they be worried to pay you 20 lakhs or 30 lakhs a year or 40 lakhs a year when you're saving 12 crore a year for them?
No, they don't mind. They
So
will be very free.
that's the real performance testing, right? Outcome which you need to reach. So do from your performance test, they have to come to a position where they can optimize their resources and they can reduce the resource utilization and the cloud expenses or the on-premise expenses, whatever they are spending on the system, CPUs or whatever, right? They're spending, we can reduce the infrastructure, right? So that is the ultimate aim as a performance tester.
मैं
That is why this is one reason why performance
मीटिंग
testing
बात करता हूँ बाद में.
always in demand. If no one is speaking, can they go on mute? I'm seeing some little noise. Sorry for that. If
I
no
think
questions,
Deepak.
please. Go on. Oh, okay.
Deepak, can you go on mute, please?
Yeah, that's fine. Maybe by mistake it would have been, but yeah, thank you for that. Okay, so so that is why performance testing is now getting more in demand. Actually, people will think, oh, with AI the demand has gone
Just,
down. No, nothing.
just
Okay,
one
I
thing.
know one of my close friends. Um, he has got a package of 800 crore.
Your friend.
Yes, I can't reveal the name.
No,
He
that's fine.
recently recently got into Facebook. That also I'll reveal. Okay,
Mm-hmm.
uh, into AI division. Okay,
Mm-hmm.
uh, but and his specialization is into resource optimization.
Okay.
Okay, so that big is this resource optimization market. Okay, it's not that small. Okay, now he's into AI.
And
His
what
PhD
is
is different.
what
He,
what is to
he's
be
a
done
doctor.
to become resource optimization? What
So
sort
that is
of
performance
knowledge?
testing. No, is performance testing is
Performance
the
testing
starting
with
point of that.
observability. Yeah.
Uh,
Performance testing, then you move on to performance engineering, then you become more into like you learn more code level I mean like knowledge, right? You need to gain, like you need to so this is a place where you have to leave the fear of coding. You have to enter into coding. Okay, then slowly you need to understand AI models like LLMs and all, how they work, how the transformers work, how the overall tokens, AI tokens work, how the computational resources when they process the AI works. All these things will come, right? Then you can reach this number of. Okay. So, but what I'm trying to say is leave this 2 zeros. Okay. At least you reach 8 crore. That is good for you. Okay. Enough. You can easily, if you go foreign and all. Okay. Not in India, I will say, but and in India you can reach even 1 CR easily if you're a good at this.
Good,
I'll say very good at this.
good coding skills.
Not only coding skills, you should be good at resource optimization,
Yeah.
right? So whatever is needed for optimizing the resource, you should know.
Honestly
Okay.
speaking, Vishnu, as of now, what our focus used to remain that okay, client is asking, customer is asking to conduct performance
Yeah.
testing, the deal close.
Mhm.
We have
Yeah.
given that okay. And
Mhm.
why this situation is there? Because they have already
So
procured
that is why
their
this
infrastructure.
yeah, that is why this number is 800 by 1000. Okay, so
10,000.
you have to go one by one to right. So yeah. So
Okay.
okay, again, see the good thing. What I'm trying to say here is don't focus on 800 CR. Okay,
No, no,
that is
no.
just a number I'm saying. That's a path which you can grow to. But the good thing I'm talking about here is the demand. There is a very heavy demand. Okay, so uh, earning like somewhere around 8 lakh to 50 lakhs in performance is a very simple piece of cake. Okay, anyone can do it. With basic performance testing, you can easily start from 8 lakh and go till 50 lakhs if you're getting into some higher experience, managerial, test manager role and all. You can easily, okay, with like let's say 12 years or 12 to 15 years of experience, you can even go to 50 lakhs in India, I'm saying, okay, easily. Okay.
Okay.
Yeah, but even like this is, I'm saying a general bracket. You can go beyond that also. Like if you're really good at what you're doing, and if you crack some good product companies like Google, Facebook, or Microsoft, they also have performance testing. It's not that they don't have it. Okay, but they have very less positions open. But when it comes, their packages are also really good, 80, 85, 90, right? So yeah, so the growth, there is a very big market, okay, for overall as the performance engineer, performance testing, resource optimization, especially with AI. It has become more because they are not getting resources, no, so they have to somehow run the things with what they have. That time our needs are becoming more important, not like before. Okay, at least we get the resource, we have to spend money. But now with spending also, they are not getting the resource. They are not getting GPUs, they are not getting CPUs enough. Cloud is getting like when we give a order to cloud says no more machines left. This is happening in real market. Okay, so yeah, so there's a shortage, right? And when the shortage comes, we have to optimize, and optimization becomes very key when there is a shortage. Okay,
Vishnu, I heard that
so
slowly. I heard that slowly Netflix will come back to on premises. I don't know why the reason. I heard this.
mhm.
Okay, when and how I don't know.
um
From
frankly, I didn't
cloud
hear
to
about this. Yeah, maybe some
okay
rumor, or maybe could be, I don't know, or maybe some reason, architectural reason why they're
reason.
coming. Yeah,
Yeah.
we don't know, because they are really good at what they do. Because Netflix is the company who created this chaos monkey. Actually, they, to make their application good, they created another tool which everyone is now using for chaos engineering. Okay, so they are such companies, like and similarly, if you see, there were many other companies like who are not in that domain, but they created that. So yeah, so Netflix, so surely there might be some technical reason behind it if they're moving. Actually, they were on AWS very heavily, that I know. Why they are moving out, I'm frankly not sure. Okay, yeah,
Yeah.
thank you for that information.
So
any
for
any
resource,
insider, any insider in Netflix?
No, no, no.
Okay,
so
okay,
for
yeah, just kidding. Yeah.
resource optimization, is there any different concepts, or it's like engineering concepts are there actually?
See, concepts are all starting from A to Z, right? If you have to reach Z, you have to learn A, right? So
Mm-hmm.
performance testing, you can say it as a, and learning coding as, let's say, somewhere around I, okay, and then going deeper into the, see, the thing is, if you want to become really good at that number, what I said, no, you have to be really good at even the compilers and all, right? Not just coding. You have to learn compilers, how this coding compilers work, right? That
Okay.
deep. For example, if I ask you to even optimize an operating system, you should be able to know that.
Oh, okay.
Okay, so that level. So don't target 800 CR because
No, my point is, if the market
no,
is
just
good
kidding.
for resource
Yeah,
optimization, so I
right, right.
just need to think of that. What is to be
Yeah, yeah,
done?
yeah. Yes, yes. So simple. For you, what I will suggest is, after performance testing, move on to performance engineering, right? Some courses you can take on that. Then monitoring, right? Someone said observability. Yes, that's a very good topic to start with. Observability is a good topic, and at the same time, leave the fear of coding behind, right? Learn some languages, right? Like at least learn in a basic way so that you can give some recommendations and all, right? For example, you can focus on one niche area like database, or the PHP, or some Java programming, right? One niche you can catch. And the good one is DB, because DB is very common, no? So you can catch one DB and how to optimize DB, right? So that is the next step. You can go niche, because
Okay,
so
okay.
till you reach DB. So how much years of experience you have now, Vikas?
I will retire.
No, 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 no. Nothing like that. Just I was going to give you a number.
17.
Right? Okay, so maybe around let's say 20 years of your experience, you might reach. If you get into some good product companies, you can nicely bargain. Okay, with
No,
a
there is
good
no
number.
scope that much. Experience is high, the scope is very less.
Yeah.
So that's why, no, that's why
That is the
Tirupati,
main
you have to get
problem
into
actually.
you have to get into architect roles. If you remain in tester roles, you will not.
Exactly.
Okay, so you have to grow. You have to go to that architect level roles, no? Then only as your experience increases, you have to increase your
No,
knowledge
nowadays
also.
architects are also very dummy people. If you Tirupati is coming to architecture, what they will do? Nothing, right?
Okay,
Simply,
yeah, yeah.
No,
simply.
no, no, not like that, Tirupati. Tirupati, don't go by that words. Okay, good to be
No,
part of us, right?
most of the companies I saw that even we are working almost more than 13 years in performance testing, but we never get that much of architecture. We learn something from architecture, right?
There are
They're not
Tirupati.
giving
There
us.
are
Yeah,
you may
maybe it
have
depends on the
not
Okay, okay.
company.
seen.
So guys, let me finish what I have started. Okay,
Yeah,
Yeah,
yeah.
we'll
please.
Go ahead, sir.
continue on this later. Yeah,
Go
yeah, yeah,
ahead,
no
sir.
issues. Yeah, right. So, yeah, so that's the thing all about. My screen is still being shared, right?
Yes, it is. It is.
Yes,
Yeah.
I'm
sir.
able
Yes.
to see.
Okay. So now we understood what's web server, what's a DB server. Now we will come into one important component called load balancer. Okay. So load balancers are not that every system will have load balancer, but mostly most of the applications will have. Okay. So let's see that what it is. Okay, I can take some questions now. Maybe I'm taking from some time now. Maybe some questions will be there. Yeah, I will take some questions related to whatever we saw till now. Anyone has any questions to ask?
No, sir. Carry on.
Okay, yeah. So next is a beautiful component called a load balancer, and I love this component because it's very close to a performance tester. Okay, load balancer, because the name itself has load, right? It's very critical component for performance tester. We'll try to understand how. So load balancer is somewhat like a traffic police. Okay, so let's say I have a road coming, and let's say 3 roads are going. Okay, and there's a stadium here. Okay, so each road will lead to a set of seats. Okay, so what this traffic police here standing, okay, he has to do is, or the person who is standing there, he has to send the traffic from here to here, here, here equally. Okay,
Screen
so
already
that
shared. Sorry, screen already shared.
is the
Yes.
screen
Yes.
shared or
Yes.
not?
It is
Yes, yes.
visible.
Yeah.
It is visible.
Okay. Okay. Yeah. So now what's happening? This way, when I distribute the traffic equally, nowhere crowd will get, I mean, like overcrowded, because equally we are distributing, and total we are leaving 300 people. Okay, so 100, 100, 100. Okay, so equally that happens. So the load balancer, right? That software that I'm speaking about is also something like this police. So let's say this 300 requests are coming. Okay, when 300 requests are coming, let's say I have CPU 1, CPU 2, CPU 3, three systems I have, okay, to handle the load. So what this load balancer will do, it will distribute the load 100 requests here, 100 here, 100 here, so that always no CPU is overloaded. Okay, it will get equal number of load. Okay, all the CPUs will get. Now sometimes what will happen, even I can program my load balancer configuration that let's say the CPU one is little big. Okay, it is having, like, let's say 8 core. CPU 2 has only 4 core. And CPU 3 also has only 4 core. So out of this 300 requests, what I will do is, instead of sending 100, I have to now send more number of requests to CPU 1, and then lesser number to CPU to CPU 3 equally. Okay, that also I can do in a ratio. So what I will do, let's say I have, so it's, let's say 400 requests now this time. Okay, let's have 400 requests. 200 I will send it to CPU 1, 100 I will 100 I will send it to CPU 2, 100 I will send it to CPU 3. This also I can do in the ratio. So let's say 2:1:1, whatever. Okay, I'm not going into ratios, but yeah, this way also we can set up the load balancer. And this type of load balancer, which is a software, is called digital load balancer. We call it DLB. Okay, digital load balancer. So it's a software running in a system which will manage the traffic. Okay, there is analog load balancer also. Analog, we call it. But analog load balancers are nowadays very obsolete. No one uses that. So in analog load balancer, what happens is there are real buttons, electronic buttons, switches. So the traffics are switched based on the switch on off. Switch will get on off, right? In that way. So hardware sort of setup, okay, where the load balancing happens. Network switches are there. So the network will get switched and it will go to respective CPUs. But this is now almost obsolete, very rare, okay, very rare applications. But now most of the applications we have DLB, digital load balancers, okay. Yeah, so that's the load balancer. In the load balancer, what happens is the traffic gets, it's the main task of a load balancer is routing the traffic. Okay, so now the routing can be done in many ways. Okay, not only load, even user agent. So what happens now? Sometimes load balancer is used to send the traffic to multiple different devices. So let's say one is coming from mobile, so it will go to CPU 1. So if something is coming from laptop, it will go to CPU 2. Something is coming from let's say kiosk, it will go to CPU 3. This also load balancer can do. Okay, so it will read the header of the request and it will see from where it is coming, and based on that it will send. Like, so for example, mobile, it will send here. If it is a laptop screen or desktop, it will send here. Kiosk, it will send. That also load balancer can do. Okay, it can distribute locations, right? If it is coming from US, send here. If it is coming from India, send here. If it is coming from Germany, send here. That also it can do. So many things, routing the traffic, load balancer can do. Okay, routing. That is where routing comes. So now, as a performance tester, how the load balancer becomes important. Okay. Now, ideal case, I said, okay, it will distribute the load, let's say 100, 100, 100, okay, out of 300 that's coming. So 1, 2, 3, C1, C2, C3. Okay. Now, due to some reason, if my load balancer is not performing well, what will happen? By mistake, it might send 150 here, and here it might send 50, 100. Okay, but what is expected? Actually, it has to be 100, 100, 100. So, what do you think? Will this cause an issue?
For sure, it will cause issue.
Definitely will
Yes,
cause
right.
an issue.
Exactly, right? This C1 will get overloaded. And when it will overload, it will crash. Now what will happen? This is not at all there. My request will either all 100 will start crashing, it will throw 500 errors or 504 errors, whatever different types of errors it will throw. We'll see that response codes, okay, soon. So it will start throwing errors. My request will fail. Okay, let's say a user is ordering, right? That request is ordering request. Ordering will not happen. Orders will fail, okay, because that traffic is not going to that CPU, right? Or what will happen if the request will go here? 100 will become 200 now for this C2. C2 will also crash. Then C3, it will become 100 again, 300. C3 will crash. So overall, your application will fail. See, due to this guy, my whole application will fail. So that important a load balancer is. So when you do a performance test, you have to clearly monitor whether your load balancer is working well or not. So how do I monitor? Simple. Let's say I have a graph. And this is a CPU versus time graph. Okay, CPU load. Generally, you will find it in AppDynamics or Grafana. Okay, you will find this graph. So let's say I have 3 CPUs. Okay, so 1 and let's say 2 and 3. Okay, let's say the graphs are like this. Now, if my graphs become like this, 1, 2, 3, is it a problem or not? So this is one thing I showed, which is the ideal case. Okay, this is where I have a problem, because let's say my load balancer is set up in such a way that it has to have a equal load on all CPUs. But what is happening? CPU 1, CPU 2, CPU 3. CPU 1 is now overloaded. Are you getting? Because it is high.
Yes, yes.
So this way we can find out, okay, there is a problem in the load balance. Maybe, okay, that also we cannot say truly surely, because there might be issue in the server also, but that's down the line of load balancer. But generally, if you see such a graph where the CPU load distribution is different for all the CPUs, especially when the load balancer protocol or the algorithm used is equal, in that cases, the problem is load balance. So this way you can figure out. So you don't need to go inside the system or check the code and all. By just checking the graph, you can say which component is at fault. Load balancer. So this sort of patterns and this sort of graphs, how to identify various bottlenecks, that we will see, okay, in the upcoming sessions, especially when we go to reporting, monitoring, analysis, and all. No, that times we will see, okay, how what all patterns you need to observe, what are the various things you need to observe in a graph. So same like a doctor, you will be in a position to just by seeing the ECG or the graph to say, okay, my system has some problem, right? Or what problem, that you will be able to answer, right? So that's where we need to reach at some point of time in the course, right? So that's a load balancer. Okay, any question, anyone regarding load balancer? So when I say a
Yeah.
load balancer, see,
So,
again, this is all
Excellent topic, Vishnu. Here, the way you give the example with the traffic and it all. Okay, we may need to have few more topics on this same load balancer once we are in the private sessions, because you have
yeah,
given the good example. Okay, like 100 and 300, more than or less than, all those things. But in terms of
correct.
technical, yeah, this very very good. I got goosebumps also while explaining this. Okay,
So that's
good
good to hear.
to yeah,
Yeah.
good to get more. Like you have given the example of that,
Mm.
which I like, mobile, laptop, and tab, like that, and location wise also, US and India and something, that the where distribution is coming and where how the allocation is going on. Um, and one more thing, Vishnu, in the load balancer, do we have multiple load balancer one and load balancer two, load balancer three?
Yes, yes, why not? Yeah, yeah, yeah. Maybe you can have a
Okay.
structure like this. Okay, for
Mm-hmm.
example, load
Mm-hmm.
balancer 1, load
Mm-hmm.
balancer 2, load balancer 3, okay, and then you
Mm-hmm.
have the CPUs. You will see this sort of architecture, especially in the microservices.
Yeah, yeah. That is what I
Yeah,
love to see this actually.
yeah, 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 yeah.
Okay.
Especially in Kubernetes and all, this automatically will happen by in the cluster.
Okay. Is there any way like LB1 is getting problem and it will shift to LB2 and LB3
Yes,
like
it will.
that?
That's why the load in the LB2 increases. No, it that also will start failing. So, but that mechanism is there, because if this is not there, a load balancer will try to distribute the load again with whatever is available. No,
Okay.
yeah.
And in the
But
times
again, see,
no.
all these are based on the configuration that you set. Okay, many things can be tweaked. So this load balancer configuration you can change. It's like writing a small script. Okay, you can
Mm-hmm.
change a lot of things there. Yeah.
Okay. Are we going to cover this topic in our actual session little more in the actual
Yeah,
sessions?
we will be covering, but surely I won't be writing any config file and all, but I will be
Okay.
explaining few more things. Yeah,
Concepts.
more
Yeah,
things
more
about,
concepts,
yeah,
right?
correct,
Right,
correct.
right. Thanks, Vishnu. Yeah.
Vishnu, just
Sure.
one
Yeah,
quick question on this load
yeah.
balancer itself.
Yes, we can.
While we are executing our load test, actually, I have never monitored load balancer. Always monitored
Hmm.
app server, DB server, and all.
Okay.
So, what
Uh,
is the tool which can be used to monitor load balancer? How we do
same
to?
tool, no? See, again, see, when I say CPUs you need to monitor,
Hmm.
that CPUs you are already monitoring.
Hmm.
Okay,
No.
you have to see that same graph.
Hmm.
So you don't need to monitor load balancer separately. You have to monitor your application CPUs system.
Oh,
It's more
okay.
like, are you getting? So it's see, like there is a flood in let's say Pune. Then
Hmm.
surely Mumbai has a flood, no? Something like that. Okay.
But load
So
Yeah,
balancer
yeah.
is a load balancer is a different mission, and app servers and DB
correct.
servers is different
Yes.
missions,
Correct.
na?
Yeah.
Then how
Exactly.
we
Yeah.
will? Because load balancer, we will get all the request to the
but
load
what I'm
balancer.
saying is when you analyze an upstream component, automatically, sorry, your downstream component,
downstream.
you automatically know the problem is coming from upstream.
We honestly speaking, our entire focus shifts on the downstream application only.
Yeah,
Honestly,
right,
that
right.
is what happened with me. I
Okay,
never
okay.
thought
But
of to
no
get it.
worries. Now it might be little difficult for you all to perceive. Slowly we will understand, okay, when we go to monitoring and analysis.
Yeah,
Okay.
Yeah.
while analysis, no, Vishnu. So, are we going to cover
Yeah.
vertical scaling and horizontal scaling concepts as well?
Yes, yes. We will be. Yes. That's where this load balancer will play more vital role. Yeah.
Okay, yeah, yeah.
Yeah.
And what is
Okay, so
actually round
yeah.
robin algorithm means in load balancer? How many is any
So round
different
robin is
robins?
nothing. See, as we have various algorithms like star and round robin, first in, first out, and all. These are some standard programming algorithms we can say. Okay, so round robin is nothing but it will keep solve. It will go to next again. So it will solve everything at the same time, but in a circle. So that's a round robin. Now in load balancer, what will happen if a request is coming? But round robin in load balancer, I had never heard about much.
No, I heard it.
Uh,
I heard it.
yeah,
Round robin.
because
Actually,
okay,
I
yeah, got
asked
it. Yes, yes,
to,
yes. Yeah,
yeah.
correct, correct. So what happens? No, if I'm correct, slowly maybe I'm recalling. Because anyways, load balancer is sending. Okay, yeah. So what happens? No, when the request is coming, let's say first request go to server A, second, but this is again the FIFO sort of example. No, so I don't know whether we can say it round robin. FIFO. I, I mean, like the naming is little confusing here because if something is coming first, it will go first, right? That way. But if the load balancer will take more time to process and all, maybe could be. Um,
That's fine, Vishnu. Yeah, maybe
yeah.
we'll
So so it's basically you can say like it will distribute the load circular way, right, among each servers. Maybe you can say that. So if the first request comes, it will go to first CPU. Second comes to second CPU. Third to third CPU. Then again first, second, third, first, second, third. So that's a round robin. Let's say I'm saying okay, like a circular way. Ramoji.
Okay, okay. And one more last
Okay.
question from my end.
Yeah.
I always confused between application architecture versus cloud architecture. And this is the one of the
Hmm.
interview question also. I am always
Okay.
failing this particularly. What is the difference between
Hmm.
application architecture and cloud architecture?
Okay. That's actually not a small question. It's little longer question, but I can answer it to you very quickly. Let me come back to whiteboard. My screen is being shared, right? All.
No.
Not now.
Oh, it's not. Okay.
Not yet.
So the question put is like, what is the difference between application architecture and a cloud architecture, right?
Yes,
Or
yes.
product architecture?
Cloud architecture.
Cloud. Okay. So see what happens now. There are various types of architectures. First of all, when we draw it and all, physical architecture, logical architecture. Logical mainly has its APIs and all. No? So how the APIs communicate and all. Now, application architecture, if you speak about, it's a very broader term. But I think in your case, it is all about that what we saw, right? Like for example, that UI, DB, and API they interact, right? So that's a basic application architecture. So how the app is built, right? That is your application architecture. For example, whether it's a microservice architecture, whether it's a monolithic architecture, whether it's a model view controller architecture. So there are various architectures, right? So whether my systems are built on microservices, then we say my application architecture is microservices. Okay, that is one thing. Now, cloud architecture is more about it's a more on the infrastructure. Okay, like for example, what the server, the database, the storage, the networking, the load balancers, though that's the cloud architecture. So what I showed here, no, you can say it's a cloud architecture. Or your see this one where is the diagram? I showed the CDN and all, no. So this is my cloud architecture, what I have. CDN, middleware, load balancer. Now, what is application architecture? I will show you. So let's say I have a front end and the front end is divided into multiple services. Let's say accounts, catalog, order, payments. So this is application architecture. A very simple architecture I'm showing. Okay.
Shall we consider like web application logic code and DB also can consider web one.
So now this is an application architecture. Did I say anything about what's the DB? What is the coding language that I used? What server I am using? Did I say anything about that? No. So in application architecture, it will be more about the services, microservices, the UI, how it is UI and all. No, but this account, catalog, order, inside that we have further. It is running on, let's say, Tomcat server. DB is MySQL. Are you getting what I'm trying to say?
Yeah.
Okay. So application architecture doesn't speak about those things. What is a web server? What's the DB server used and all? It will speak about the coding and the development that how we are going to do, right? How it's getting developed.
Okay.
Clear, no?
What is the fourth one? Account, catalog, order, and the fourth one, what you have written?
Payments.
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 Third-party systems.
They
Correct.
are the
Yeah.
different
Anything.
functionalities of this particular application. Each and every functionality having their own servers list.
Services. Yeah. Basically,
Services.
and so when I say services, they have different resources also, set of resources, and they all communicate using APIs. That see this thing we will discuss very detail. Okay, when we go to distributed systems, we will discuss this. Okay.
And if quickly you can explain that what is microservices architecture?
Now it's a high jump. Okay, I'll explain it later. Wait for some more time. Okay, soon we'll reach there.
Okay. Okay.
Yeah. Because if I say they are independent services and all, you will not understand much. Okay, frankly,
Okay.
I would like to put it in a very beautiful way because it's a beautiful concept. I
Mm-hmm.
don't want to miss that excitement. Okay.
Okay. Okay. So in
Yeah.
this application architecture, actually you have explained that there are multiple applications and they are interacting with the API calls. Correct? That is
Okay.
what.
Yes. Correct. Now, if I want to answer it in an interview, someone asked like it's for an interview, if I want to explain what's an application architecture or cloud architecture, application architecture is the design of the app itself. Design of the app. Things which I write very slowly, those you can note it down also, okay? Because maybe that might be very
Yes.
useful ones. Those which I write very fast, maybe, or something like which I scribble, maybe you don't need to note down. But yeah. Next, cloud architecture is the design of how the app runs on the cloud infrastructure. So, is the design. I don't know, my pen is not working. Is the design of how the application works on cloud infrastructure. So this is basically the main difference. Okay. So that's the difference with app architecture or cloud. Even I can say cloud or on premise, anything. Okay. On premise. You just need to change this word with that. That's it.
Vishnu, I have a basic doubt, please. So,
Yeah.
application architecture within application architecture, can I say that it's the only monolithic or cloud is a distribution system? Otherwise, in the application architecture itself, monolithic as well as a distribution system is there. Distribution like
Yes, it's there.
microservices,
It's there.
it's
Yes,
there, right?
we cannot say that application architecture will have only distributed, only monolithic. All have because application architecture is all about how you are going to code and develop. No,
Okay, it's purely depends upon the design. You mean to say
correct. Yes, design. Yes, exactly.
it can be monolithic, it can
So when
be
you speak
SOA.
about application architecture, you never
Mm-hmm.
speak about resources. That is out of the story. Okay, but when you speak about cloud architecture or on-premise architecture, that time
we
resources will
have
come
to
into picture.
highlight
Yes, correct.
resources as well.
The load balancer, CDN, web
In,
server, DB server, different resources that we are going to use. Yes, those.
in terms
Okay.
of document, if I ask, so
Hmm.
does it mean that application architecture gets covered in HLD document and
Vikas
cloud?
has full focus on documentation.
Yeah,
Sir,
because
I'm
that is
trying to build my understanding actually.
Yeah, yeah. Right, right.
and and cloud architectural is that the infrastructure
Correct.
uh,
Yes.
okay, got it.
Yeah. You send me your documents, okay, once you create it. It will be good for me to just review and read.
I have already created. I have floated it with customer as well.
Okay. Nice.
Yeah. It's a basic test strategy document. It was so
Yeah, yeah, yeah.
nothing much was
Yeah.
there, but I'm actually doing it very first time for the web application.
No,
So
that's good.
I
Yeah.
was
You will learn a lot. Yeah.
nervous actually, honestly, and
Yeah.
I
No,
know.
that's a good thing to do, especially if you're in a higher experience range.
Yeah.
Everyone should do that. Creating test plan, NFR. If you get a chance, create an NFR, which is very difficult. Okay. Then test strategy, because if you can create an NFR, like get into some proposal creations and all. Okay. So that way, what will happen? No, you can slowly grow into that. Because that's when you will actually have a complete knowledge of what's happening, right, with the customer.
Yeah. Actually,
I
I was
have
an
good.
tower
I'm good
lead.
in that, Vishnu.
Yeah, yeah, that's good.
Very
That's
good
good.
in NFR, test
Mm-hmm.
plan, test
Yeah.
strategies,
Okay. Yeah, yeah. Hmm.
all those
That's very
things.
good. Okay, because there are a lot of things to be considered in that. No, so that's not that
Yeah,
easy like people think to create.
workload models, all those things.
Without any escalation, if you can finish a project, okay, and the person who created the test strategy, test plan, he will get the hats off. Okay, so
No,
so
here
that's
and
the
there,
thing. Okay,
multiple rounds of versions will be created. Version one, version two,
correct.
version three, definitely
Right, right.
before sign off.
Yeah,
Vishnu, on
yeah.
that note, again, one more question. If I'm not getting the required throughput, that what is to be achieved, how should I handle it?
Ganga said no already. Version two.
No, that is fine. Version 2 is
That is
okay. It's
so.
under review only. But if I'm not
No,
getting
that's
the
fine. That's fine,
No,
Vikas. No, see,
there are
now
fine
what you
tuning
have
because
is
okay, this is
correct. Yeah.
maybe this is not the correct form at this moment. Definitely, we can discuss more and more and during that session.
Ganga,
Okay.
actually, I'm
Yeah.
asking because I need to get it delivered. That's why I'm
Right.
just taking the
Yeah,
right inputs from
Maybe
it.
I can
Vikas,
understand.
maybe
Yeah,
Ganga and you can get into a call together sometime.
that's
Okay,
fine.
it will
Yeah,
help you both.
definitely. Whoever wants that, okay,
Yeah.
any
No, no.
support kind
Why?
of.
I'm not kidding. I said it purposefully because Ganga is saying he has worked on strategies and all. No, it will be helpful for you, Vikas.
Yeah, that's fine. But if you could just give
Yeah.
me one statement that will suffice for me.
Oh,
If
okay, okay.
I'm
What's
not
the statement
getting
you
the
want? Yeah.
if I'm not having the
Ah.
throughput that what we actually need to achieve for putting 100 concurrent users as a load,
Mhm.
but they are not able to define me the throughput or
Okay.
TPS. So what should I do in
Mhm.
that case actually?
See, now this is where experience is one thing will come into picture, and
Hmm.
also if they are a live application, you can analyze their
No, it's a
production and find
greenfield
out.
application.
Ah,
Greenfield
so
application.
again, experience will play a vital role in deciding the throughput of the transactions and all. So you
Hmm.
have to maybe you can take help from someone who has worked on similar applications.
Hmm.
Understand the user behavior of that. Speak to the customer and understand like how many users they have.
Even they
What are the
don't
general
understand
user
what I am asking. Point is this: they are not able.
users they will understand, no? Like they are getting money, no? So they surely should know the count of the users at least. 1 lakh
100.
orders they are getting.
They have given user count as 100 concurrent user. That's it.
Yeah, that is more than good enough. You can just translate that 100 users to some initial TPS using the little slow and all.
So
Okay.
there are
Yeah,
lots of parameters,
otherwise,
factors,
s- small inputs
because
here.
Correct. So we will understand that, Vikas, okay, when we
Okay.
Yeah,
discuss.
because you can do two options here. One possibility is increase the number of users, but in your case, the number of users is 100. Okay.
Yeah.
But your throughput should be increased. So you have to go to second option. decrease the facing time and think time, and you can hitting the more number of hits, it will increase the your throughput without changing your number of
No,
users.
no, I'm not asking that. Okay, maybe I'm not able to put my words correctly. I am
Okay, I'm
asking.
just stopping the recording.
Yeah,
Okay,
Yeah,
yeah,
that
better. Yeah, better. Yeah.
yeah.
it is
And
about
others,
that.